This is the project that I'm working on today. This is a large steel nut for a telescopic cylinder. This is one of the nuts that screw onto one of the chrome tubes, and the packing goes in here. So right inside this area here is where all of your chevrons or your V packing goes in there. And then these threads here is where this large bronze packing nut screws in, and that's what compresses the packing. And your tube slides through this way right here. This also serves as a guide bearing, just like a rod gland. And you can see that it's split. And whenever we were going to take this thing off of here, it had galled it really bad and just couldn't get it off. There's a couple bad spots where it started it right there. You know, you get just a grain of sand, anything in there, and it'll start galling really bad, and then you can't get them off. So the only way to really get it off is to split it and try to swedge it, spread it out some, and get it out of there. So what we're doing is replacing it. We're making another one, and we also have there's a shoulder inside here. Probably hard to see, but there's a O-ring groove in there, and that's what seals the end of the tube right there as well. So there's the new material. The OD of this is 13.5 inches. I believe the ID was either 8 or 9 inches, and I'm getting it roughed in now. So how many of you guys are still using your vernier calipers? I've got mine and I still use them. I've talked about this before. They're still an excellent tool, very valid for jobs like this. They're easier on jobs like this than a standard, say like a digital 12-inch caliper, because of the way that you have to hold it. With a vernier caliper, the reading is right there in front of you. And I was getting this bored into 10.5 inches right here. This is that bore that I'm making 10.5. I wasn't getting very good chip control right there. I should have swapped out the insert, but I started making the finishing cuts and I just rolled with it there. Oftentimes whenever I am using my vernier calipers, I'll come back and I'll check it with an inside micrometer. That's my stare inside mic. And I like to do that sometimes just to, one, keep the practice up on using both of the tools, and also I like to use both of them to verify the same measurement. In this case, I was shooting for 10.500, and I believe it was 10.501 is what I hit, and I was trying to show that to you right there in the shot. Once I've got past that 10.5 inch smallest bore there, now what I'm doing is counterboring it for the area for the packing, the V packing. So I'm doing here, taking 200,000 pass, the no good method to help keep the tool cool. Here I'm doing my finishing passes. Backed off on the feed, increase the RPM. Went with a 431 insert here. I just made my final cut in the bore where my V packing is going to go. It slides in there, shoulders out, and then I got to counterbore it here again and thread it for the packing nut to screw into. I want to go ahead and check my sizes and see. I was shooting for 11 3/8, which would be 11.375 inches. All right, I got 11.376. Not bad. 1/1000ths over my target. So I'm going to go ahead and finish doing the counterboarding here, and then I'll show you some threading. We're now on our threading. I've got everything set. We're going to go ahead and make a scratch pass and check our pitch to verify it. We're cutting 10 threads per inch here. we've got our cross slide set to a 0 on a hard stop for the threading collar, and I've got the compound set to a 0. And we'll bring it right back to that 0 right there. Pitch gauge set on 10, and that's good. Alright, we're cutting 10 threads. Did you see that? Those chips come through the back side of the chuck there, or behind the part, and started whipping around. So in that situation like that, just try to remain calm, shut the machine off, or stop the spindle, let everything come to a stop, and then let's deal with the chips. As with my usual fashion, I usually thread it a little bit light. I don't go full depth because I like to check these parts and make sure they're fit. That's usually how I tell. I can feel something and make sure that it's fitting properly. So I don't go full depth. I go ahead and grab the part and check it. And in this case right here, I ended up being a little shallow. So you see it starting to get snug on me right there. So I just stop. We're going to go ahead and back it out, and we're going to make one more pass across there. So I made that one pass through there, and I could tell by the cut that it took enough metal out of there for that thing to go. So I just left it at that one cut, hoping that was it, and it turned out that was exactly what it needed right there. So the packing nut fits in there great, and we're good to go on that side. We're going to go ahead and we'll back this out, and I got a couple shots of doing some polishing on the threads, and I'll show you how we do that. We got these little polishing wheels made by 3M. They're gray in color, and they're basically the gray Scotch-Brite is what they are, the fine Scotch-Brite, but they're pressed into a wheel that you use on a die grinder. And these things have many purposes around the shop, but they're for polishing and deburring is what they're mainly used for. And we use them quite a bit on threads, especially parts like this. You can see right there that very last thread, I was coming in there, and it was pulling it out of there. It was polishing it. There I am hitting the very front one. Usually that one does the same thing. It tries to roll an edge over on you. So I like to take that wheel and polish that front edge and go through there and let it polish the actual thread too. And then I'll focus on the back area, which is what I'm doing right there again. When you come through that very last thread, it always leaves a nice jagged, sharp edge in there. And it's also a place that could be susceptible to cause galling. So I use those little wheels right there. They're safe, and get in there and polish that stuff out. And of course, again, I got my PPE on, earplugs, and a face mask. This is just one way to get it cleaned out after you go in there and do some polishing. We like to use those little sure shots, and basically it's like brake clean that we use for a cleaner. Real safe. Get in there and spray it out, wipe it out, and then just use the air to try to blow the rest of the dust out of the threads. last machining step to do on this side of that nut. I'm setting the compound at 20 degrees. I'm going to machine a bevel on where the shoulder is that leads up into where the packing goes, and that gives you a nice lead in for the packing to be pushed into whenever it's being installed. Something happened to the audio on this clip. I don't know what it was, but there you can see I'm machining that bevel that I was talking about. That helps the V-packing start up in there. And I'm taking a total of 1/8 of an inch. Once I touch off on the corner, I just dialed in 1/8 of an inch, made 3 passes there, and that was plenty for that. All right, John, I want you to pay attention here now, because when I come up there for your open house, I'm going to test you on using the big boy mics. I seen you use the 1 inch, and you had a lot of questions about the proper way to use them. Here you go. You were on the right track. Mount it solid on the anvil side of it, and just rotate it once you find the center, and you get your measurement. It's all about the feel, man. I'm going to finish that OD there at 13 1/4, 13.250. So I got this side ready to thread. This is the side that's going to screw onto the large tube over there. There's going to be an O-ring machined in this face. That'll be the last stop that I'll do after it's threaded. I've got a special tool that I've ground, high-speed tool, to get in there and do that groove using a 2-inch Allure boring bar. I'll point out that I do have an undercut in there, a radiused undercut for the threads. I use this tool right here, piece of 1/2 inch high-speed steel. I get in there with my 2-inch Allure bar, cut that out, widen it out just a little bit more. So I've made 1 scratch pass, and we're cutting 8 threads per inch on this one. I'm checking it. Remember, always check it, make sure that you're right. Looks like that I'm on it, 8 threads per inch. So I'm gonna go in there and get this threaded out. This side right here, I don't have nothing to measure this. And what I'm gonna be doing is threading it to fit on the tube. So what I'll do is thread it to what I think is the correct pitch diameter, according to the numbers. And then I'll take it out after I cut the groove first, and I'll try it on that tube. And that's usually how I do these. I'll check them, and if they're tight, if they don't want to go on there, then I have to set it back up and chase a little bit more out of the threads. That's usually the case for this kind of stuff right here. I'll point out too that I've got 2 references that I'm going to stop. One is just watching it fall into that groove, and the second is I've got a dial indicator set up over here telling me when I'm in the middle of that undercut. Right there, I had disengaged the half nuts after I engaged them. I didn't like the way they felt going in. You know, that's an old machine built in 1943. It's got wear on it. The half nuts being one part of the machine that's got some wear. So when you use that pacemaker, you have to be familiar with it. You have to get familiar with it, know the machine, just like all those old machines. And the threading on it it's very picky. You have to make sure that you engage properly. If you don't, you're going to be to one side or the other of your thread that you're cutting, and you'll be cutting into the side of it more. So you just have to, you got to get a good feel on that machine on how to drop the lever and get those half nuts engaged properly on that screw every time. I'm going to use a little bit of cutting oil just to help lubricate this, lubricate the cut, try to keep the chips from sticking in there. We're getting close though. I'm going to leave it right there. According to my compound, I'm about 10 thousandths off of being what the actual proper depth would be if I was going off the numbers. But I want to leave it a little bit light because I got a feeling that this may already be fitting on there like it should be. So I'm going to polish them like I showed you before with the little Scotch-Brite wheel. Make sure that there's no sharp and jagged threads. The ones in the very back there, that last one, it looks like a saw blade. I like to eliminate that stuff, and especially this leading edge right here also. Get in there and polish that out real good. And then clean it. We'll get that done, and then I'll move on to the O-ring groove. So we're setting up to cut that O-ring groove on this face. Again, that's where, when this thread's onto the tube, it's gonna seal on that O-ring right there. So I'm cutting it for a number 371 O-ring. I believe that's right. I need to confirm that. Now I can't remember since I walked over to the camera. I've got it all wrote down though. It's for, the O-ring is 11-inch ID and 11/3/8 OD is what it is. So I'm using this 2-inch bar. I'm using the 45-degree end of the bar. That's one of the reasons why I love these type of boring bars, is that you've got a 90-degree end and you got a 45-degree end on these bars. And Aloris always makes fine tools. So here's the tool bit that I was talking about that I made to get in here and cut these O-ring grooves, because I've never had the proper, say, carbide indexable tool to come in here and do a face like that. I've never asked for one. I just grind the tools when I don't have what I need to get the job done, instead of waiting around for weeks. So I've been using this piece of 1/2-inch high speed. This is actually cobalt, high speed cobalt, Morse tool. It was a little bit wider at one time, and then I ended up using it for some more narrow width O-rings. So I'll end up having to step it over to get it to the right width that I need. So how I ground this, I go off of the 45-degree angle that's in this bar. And you stick this tool in here, and that is on a 45-degree angle right there. So I need to make sure that this cutting face is square to that face in there coming off this 45. So here's a little trick that I use whenever I grind it. I use a centering square. This is my little Lufkin right here, and the rule. And you can use something like this, and as you're grinding it, make sure you're getting a good shot. You can use this as your reference to make sure that you have that cutting edge 45 degrees off of the side of the tool bit there. See? I keep missing it when I'm pushing it up there. There you go. So that face of that tool should be square once you stick this in here on the 45 and come up there to that face. Now you got to make sure that your tool is square. I always take these tool posts and these tool holders and I indicate them. I usually indicate this side. I run the cross feed back and forth until I bump it around nice and square within, let's say, 1/1000ths on the length of this DA size tool holder right here. So I think we're ready to go now. I've got to get my offsets and everything set. We're going to go ahead and just stick the tool in there somewhere about right there. Go ahead and lock it in. Now what I'll do is I'm going to come in here and I'm going to touch this ID. That's 10.5. So I've got the width of my tool documented over on my notes over there, so I know how wide that is. I come in here and touch this ID, and then I know where my offset will be to get me on an 11" on the inside of that O-ring groove. We'll get all that set up and then we'll start cutting it. I want that tool just to touch it. There it is, it's just touching it. Alright, so we've got it offset. I moved it over the width of the tool to make the right side of the tool even with the 2.5 bore here. And the idea of our O-ring, I was wrong. It was a 379 O-ring, not a 371. 11 inches on the ID. So I've offset it a 1/2 inch. I actually added about 20 thousandths to it just to get it away from that side a little bit, because the ID of the tube is right at 11 inches also. So we should be set. We're going to go ahead and touch offset a 0 on my dial over here, and we will go about 150 thousandths deep, and then I'll have to offset it to bring it to about a 1/4 inch wide on the groove itself. And you got to take it easy with this. Use plenty of oil. Our edge is nice and sharp because I touched it up. I'm squirting it on the other side here to try to bring it around to the tool bit. And I've just got my left hand on the hand wheel. I'm hand feeding this in. It's going to take a little while to get in here, because if you try to plow that tool in there, it's going to try to bind up on you. It's going to load up on the tool. The steel seems to sometimes like to weld itself to the edge of those high-speed tools, creating a lot of like galling as it's trying to cut, and it'll sound like it's just about to rip it out of there. That's right there is 40 thousandths deep, so we got another 110 to go.
I apologize about that blurry spot there on the screen. You've probably seen that. There's a little drop of oil that splashed up there on the screen on the camera, and I didn't catch it. I wasn't looking at that. A lot of times whenever I'm busy doing this work and I got the camera there next to me shooting, I'm not always looking at the screen of it to make sure that it's clear oil or fingerprints or coolant or something like that, which is something that I actually try to do, is always keep the screen clear. So it's one of those things that happens, and it's going to happen again later. But you can still see the cut there.
Alright, I got the thing offset. Now it's time to go back in and cut it one more time to the right width. Yeah, we're gonna make this about a 1/4 inch wide. A little bit easier on this cut since I'm not cutting the full width of the tool there. And once you get the first groove cut, it kind of gives the chips a little bit more clearance to evacuate.
Another clip here where I lost all my audio. Actually, I didn't lose it. It's got a lot of weird noises coming out of the mic there. So I don't know what's going on, but I think my adapter cord for the mini USB to the 3.5 mil microphone adapter, I think that cord is messed up. So I need to go ahead and jump online and grab me another one, and we'll see if that corrects the problem. But here I am just test fitting that O-ring, and it fit fine. It fit good. And I checked it with my digital calipers before this, and the depth was right on. It's spot on what it needed to be. So we've got a good fit there. That tube is going to screw into that, and the face of it is going to seal off on that O-ring right there. I'm going to give you guys a sampling of that bad audio. See what you think.
Not radial group, that axial. That's what this would be. Got you sitting on the tube. This is the threads that I had to chase because they were galded real bad, obviously from the nut. There were some really bad ones there on the first couple of threads, so I actually just turned those off and eliminated those and then chased the rest of them. I actually skint this down about 20 thousandths and then lined it up and then cut them in there again. So we're gonna go ahead. I've already blown it off real good. I'm gonna squirt some of this coil on here, and I'm gonna squirt some in the nut. I'm gonna bring it over here and we're gonna try it. I think we're going.
How was it?
It's going.
Yeah, we're on first try.
We're about to find out. It's going on there. We're just about pulled up. That thing's got a good fit on it, man. Just a little bit of wiggle. There it is. It's up on the face there. All right. All right, we got this one done. Like I said, all we got left is the set screws that I got to put in it. I'm not even worried about filming that, but this one's done.